Hello everyone. Today I will be presenting the project report of Uber supply demand gap. This is the raw data that we have with request ID, pickup point, driver ID, status request, timestamp, drop timestamp, and travel time. And while in the cleaning process, I have separated the request and timestamp with date and time respectively, and drop as well with the date and time respectively. And I have created a calculated column where based on the requested timestamp I segregated into morning, evening, afternoon, late night into 6 categories. And I have created a calculated column travel time where I this is the difference of requested timestamp and drop timestamp into hourly basis, and also created a calculated column for distance for how long the passenger is traveling using the Uber service. For less than 30 minutes I've used it as near, for 30 to 60 minutes I've used it as a medium, and for more than 1 hour I've used far. And also for the status where there are cancelled trips I used as unknown. Also for no cars available I've used unknown. So yeah, that is what I've cleaned the data in the data. And coming for the first dashboard and pivot chart, I have I have segregated the I have created a chart for the air pickup status with respect to the day categories, and also created a chart for this with showing the count of how many trips were made during the day categories from respective airport and cities. This is the supply demand chart for the distance travel for medium, near, and far with respect to the pickup point. This is the pivot chart for number of rides for in the day categories. As we can see that morning and evening have most of the pickup categories. See, like 1893 and 2517. These are the segregation of categories from pickup points. As we can see that airport from airport we have no cars available is the highest, and trip completions from cities are mostly highest. These are the airport pickup counts for the each and every driver. There are around 300 drivers and their respective pickup points and trips and their grand totals. As we can see, we have all the totals, and from city and airport, each driver has made many contributions to the Uber company. And here we can see the supply demand for the counts, how many counts from the pickup point from the airport and city. It's not like the travel is very inclined to one particular pickup point. We have around 48 to 52%, the same, almost the same range of trips from both airport and city. Here we can see that the number of ride counts for each rider. We have around 300 riders, and here we can see the 300 count for each and every driver. We can see how many counts we can there are. For example, if you want to see 86, count ride number 15. For ride number 112, here it is 112, 113, 112 rides, 14 rides. This is the number of cancelled Uber counts due to because of no availability or change of mind. Those are totally 2650 cancelled rides. These are the charts that I have, few charts that I have designed for the Uber analysis. And now coming to the Uber analysis gaps EDA. This is the project summary. The general project summary is like around we have the data like 600, 7,000 records, and also I have, as I have told you that I have separated mixed data types of the Uber pickup points and drop points, and I've also added and yeah, I forgot to tell you that I've replaced the NA values and left it alone, and I created the day categories that I've showed you earlier, the travel time, the request the travel time difference between the requested timestamp and drop timestamp to give better analysis, because we can see how far the person is traveling. And I've yeah, that I've changed the request and timestamp and split them with this yeah, the dataset is ready for execution. And I've also, and now I've imported this to perform analysis and to create charts, and I've also shown you the dashboards that I have built in the Excel dashboards, and I've also created few charts for analysis here. And later I've also created SQL insights that I will show you later. And yeah, I've handled the data for format and handled missing values. And yeah, this is the GitHub link. The problem statement is to find the insights about Uber supply gaps from airport and city. The business objective is to maximize the fulfillment and minimize cancellations and unserved request by the identity demand gaps in the Uber rights request system. And the data, as always, we have imported pandas numpy, and to plot the maps I have used matplotlib, plotly express, and seaborn. This is a dataset, the clean dataset that I have used, the same data. This is the same data set I have used in the dataset loading as well. This is the first view. As you can see that we have all the updated columns. There are 6,745, more than 6,700 rows and columns. This is the information. We have driver as a float, request ID as an integer, pickup point. All these are objects. If we want to find any duplicate values, there are no duplicate values. There are few null values where we can see that 2650 is a driver ID null value. This 2650 count is from where there are no cabs available for the Uber ride. Along with the cancel ride, there are around 3,914. So that's why we can see 3,914. I don't want to handle these null values, because if we handle these null values, there will be no point in finding any analysis, because most of the cancelled trips and no cabs available trips will be gone. So we cannot find any analysis based on removing all these dropping these cancelled trips and no cars available trips. If we remove this, we will not be able to handle unknown data. So yeah, so as I've told you that there are 2,650 cars, no cars available. These are the null values that they have shown in the data set for the driver ID. We can replace these with zeros because we don't have any value, and it is also easier to perform an analysis. Yeah, that's the dataset that's the insert that I have found from the dataset. This is the general information from my dataset. The request ID for this is the unique ID for each passenger or each trip. The pickup point is either city or airport. The driver ID, the unique driver IDs for 300 people. The status whether cancelled or completed or no cars available. The request timestamp when the trip was initiated. And the drop time was when the drop time was completed. The travel time, this is the fields that I have created. The travel time, the duration between the request and drop, and the distance covered, whether it is near, medium, far, or unknown. The day category that I have told you that I have created 6 categories. Mentioned few here, and these are all the columns that I have. These are the 11 columns: request ID, pickup point, driver ID, status, request timestamp, day category, drop timestamp, travel time, and distance. These are all the 11 columns. When I wanted to describe the dataset, most of these are object data types. So the request ID is an integer data type, and driver ID is a float data type. So we see these in the standard deviation mean and all the variable count. If I wanted to see all the data sets, so I have also included the object data types to see all the data set values. So as we can see the how many unique values in the data set, which one is the top value, how many what is the frequency of it. That's what I have described here. These are all the unique values present in the dataset. As I have told you, based on this dataset, what are insights from this, the same in the unique values. In the data wrangling, the data I have handled is that, as I have told you, that I will be filling the NA values with 0 to perform an analysis, and I have created a separate calculated field just for the calculated trips which I have used in charts, and few incomplete trips as well, which is having the status that is cancelled and no cards available for analysis, and also unknown trips which have the distance as unknown. This is the same as incomplete trips, and this is the same as incomplete trips that I have used in charts only for a single chart. This is the same head. As we can see that the driver ID changed from 1.0 to 1. I'll show you the driver ID. Here it is a float data type, and here it is a integer data type. See, here is a proof that I have changed that into integer data type, and I have created the calculated fields. This is the first chart, that is the bar chart, univariate bar chart, which is a count for the city and airport. The second chart is also a univariate bar chart for how many status for what is the status count for the number of the different types of trips. This is an insight for to see how many at which day category, how much is the count of each day category. In the fourth visualization chart, I wanted to show the incomplete trips that are there from the pickup points, and that is segregated by each day category. As we can see that in the morning most of the trips are cancelled, and in the evenings the demand of cars is very more, and the supply, and in the mornings we have excessive supply for the cabs, because you can see so many cancellation trips there. And the fifth chart is the visualization for the bar chart count, as the same univariate chart, and I've segregated these with based on the status to show the count of the number of trips performed at airport and also at the city. These are the average times that people traveled in using the Uber service based on the day category. As you can see, no matter the day category, the average time they traveled is around 50 minutes to 55 minutes, and most of the values that include from 40 minutes to 65 minutes in the same time for each day category. And also I wanted to see how much distance the passengers are traveling, so I have used the distance count, and by using as a distance I have segregated, and to show that the most of the people are traveling from 60 to 30 minutes to 60 minutes at least using Uber service. Uber can provide either coupons or promotions for these people. As I've told you that we can provide discounts to the people who are using the service. From the airport, segregating into the day category, I wanted to see the count of the people who are using the Uber service. As we can see, in the evenings people are using from the airport more, and in the mornings people are using more from the city. This is a visualization chart that I wanted to show how each sector is related with each other, how each category is related with each category based on the count. As we can see, morning in the cities are more dominating with 1952 count, and in the evenings at the airport it's more complicated with 1417. As you can see, of all the six categories we have with respect to each other. And in the chart number 10, I have shown the correlation heat map between the pickup point and the day category. As I have told earlier, we can see that in the mornings we have a heavy count for the people traveling and using Uber. The demand is more for the cities in the mornings, and demand is more for the airports in the evenings. As I told you that, I have mentioned the same in the insights as well. Here we can see that the pair plot with the request ID and the driver ID. We can see that the all everywhere the IDs are scattered, and driver ID is more for the zero because most of the as you can see, the count is more for zero because most of the trips are cancelled or either no cars are available. This is a chart I wanted to show where how much people are traveling the most. As we can see, we don't have a significant rise for each and everything except for the people traveling from medium distance in the mornings. As we can see, that has a significant high values, and most of the trips that are cancelled in the mornings are more, and also in the evenings because these are in the cities and these are in the airports. And the last chart that I wanted to show is the bar chart count bit for the day category, for the trip count between city and the airport. That I have told you that in the mornings we can see that there are heavy users for the Uber, and in the evenings we can see that there are more incomplete trips. So these are the insights that I wanted to show, and the conclusion is by with the analysis for this, Uber should take care where to use and where to provide and supply more Uber drivers based on the incomplete trips and the no cards available trips. And now I'll show you the insights for using that I have used with SQL. These are the few SQL insights that I have used, and I've used VS Code to find the insights. The first insight was to show the whole data set, and the next insight is the general data set about general information about the status, based on the status, to show how much each trip contributed, each status contributed. And the second trip, as we can see that the 41% of the trips out of the total trips are completed, and out of the 6,745 trips, 2,000 trips are completed with the total completion percentage of 41%. As we can see that the individual count from the pickup point, airport and city, which is segregated for day categories. And I have also given detailed information about the pickup point and the status of the each status of the pickup point, and also their count, which will be insightful for the Uber to know how where to provide cab service, and where to remove the cab service where the demand is high and the supply is less. The fifth category is to show the total trips that are performed with respect to the day categories. The sixth insight is to show how much people are traveling with respect to the pickup point, and these are the top drivers that are traveling, that have more demand at the airports with respect to the airport as the highest demand. Number 225 has the highest demand. As you can see, he completed number 10 trips just from airport and 3 trips from city. So mostly we can say that he is the top demanded driver. The insight number 8 is to see the completion rate and the incompletion rate from the each pickup point. It is segregated that 59% is the incompletion rate from the airport, as no cabs are available. And the insight number 9 is to see the total count of the passengers traveling using Uber and how much they are traveling. Mostly we can see that from the airport, most people are traveling medium distance, at least 30 minutes to 60 minutes. This is the average time that they are spending. As I've told you, most people are using medium travel service using Uber. You can see that the most travel time is greater than 30. So this is what I found from the insights using Uber, and this is the Uber report that I have produced using all these data cleaning and the dashboards, the same dashboards and the exploratory analysis that I've showed you earlier, and also the SQL insights. Each SQL insights I have showed you 10 SQL insights, and these are the solutions and some conclusions that I have made using the analysis that I have performed. Deploying more drivers at the airport can reduce trip cancellations and increase the availability of cars. Provide coupons for the clients who travel more. Obviously, it will it will provide more user trust. Give incentive for the drivers who are working for peak hours. Obviously, if someone is working at overnight, we can provide some incentives for the drivers. Implementing cancellation charges, because most of the drivers who change their mind to cancel the drives should be certainly compensated, not much. And these are the conclusions regarding the whole project. The goal was to understand Uber ride patterns using the real-time data, where we have more supply, where we have less supply, where we have more demand, where we have less demand. And I have cleaned and transformed the data using Excel. I have showed you earlier the Uber dashboards and the clean dataset and the new dataset. Performed EDA and EDA analysis in Collab. I have found a few SQL insights that I have showed you using VS Code. I have built the dashboards that I have showed you, and I have also provided the key solutions that Uber might involve and create and perform, so that it can improve the Uber business. Thank you.